What's up, everybody? Good morning. How are y'all doing? Hope everybody had a good Christmas, good break, back to work. Okay, so what are we doing today? Trying to finish this stuff up. So I've been working on this immediate draw utility. It's gotten a little more fleshed out, actually a lot more fleshed out than it was last time. I actually can't remember what I was looking at last time. I think it was just getting like, maybe had like a sphere drawn, but then I was running into issues when I was going between OS X, Linux, and then Windows. I was noticing that there were issues with some of the command buffer submission, which I thought was something to do with the mem copy, but it turns out it was actually something to do with just simple initialization of some of my immediate mode cache structures that I have. So if I look at, let's see, so for the immediate mode, this is the immediate mode object. What it holds is a vertex buffer and an index buffer for all the pulled vertices and indices for the debug objects you can draw. Holds a default texture, and then it holds this hash table of pipelines. I'll go over that in a second. Uniform buffer for all the uniforms to upload. Sampler buffer for the same thing, for texture samplers. And then a dynamic array of vertices. So it's just immediate vertices that you pull up, and then a dynamic array of indices. Okay. So this is a uint16, so that means that for the indices there's going to be a cap. I could probably make this a u32 and not worry about it, but for now, u16. And then it has this cache. So for the cache, what it does is, I could actually get rid of this, not really caring about stacking pipelines, but it has a stack for all the model view matrices, a stack for all the projection matrices, has a stack for modes, but again, I can get rid of this as well. Well, no, I need to keep that, because what you do is when you push on a particular matrix type that you want to mess with, I guess, multiply through with, you need to keep track of which mode you're in. And then it has a cached UV coordinate, so you can call something like GSI texture coordinate to F, give it the GSI object, and then what you want your texture coordinates to be, so like a U and a V. That sets that into the cache, and then any texture positions that you call later, which again, if you're familiar with immediate mode for OpenGL, this is kind of how this works. Then it binds this texture coordinate to that vertice or vertex. Same thing with the color, it does the exact same thing. With that, you call, let's see, C4UB, so color for unsigned byte. And then it holds a reference to a texture that's bound. So if you want to pass in a custom texture, you can do that. And then it holds a pipeline state attribute struct. And this is actually what you use for the internal pipelines. So what I was dealing with, coming up with a design for this, was how are you able to control certain pipeline state? Like if you want depth enabled, if you want to set the blend mode, like the primitive type, stuff like that. Because this is following a not an implicit pipeline, it's following a more explicit pipeline. So how do you deal with that? So what I came up with was creating this structure here, which has these configurable options. So you can enable or disable the depth, enable, disable stencil tests. You can enable, disable face culling, enable and disable blend mode, and then you could set the primitive type. So right now there's two primitive types, lines and triangles. So with all those, you get 2 to the 5th potential pipelines, so 32 generated pipelines that we'll have internally. And whenever we actually create the GSI object, so down here, where we're actually creating all these pipelines, so we go through and we just enable these flags, push those back into a pipeline descriptor, and then we create the pipeline and then push that back based on the attribute. So another bug that I was running into was actually with the hash table. So this hash table that I have, I go to it. This might be kind of strange because this isn't necessarily, well, maybe you can do this in C++. Maybe the unordered map does allow this. I think you have to provide a custom hash function for it though. I don't think you can just do it straight up. But for this, my hash table, you can take any generic structure and you could pass it in as a key, and internally I'll hash those bytes down to a 64-bit hash. So this is a hash on the state attribute flags, and then that returns you back a pipeline handle. So if you have something where you have you want depth enabled, stencil disabled, blend enabled, you want face calling, and then you want lines, that will be a particular key that'll hash down into, or it'll hash down to a key to give you a very particular pipeline back. In fact, a unique pipeline back. Again, there's 32 of those that are generated. So the issue that I was running into with the hash table, let's see, there's a get function, yeah. So this is what I use to actually get, because internally the hash table is just, it's just an array, right? It's an array of entries, and that entry is key, value, and then a state, right? So it's just a big array of this. So it's a linear array. What I was running into was like stride issues with byte alignment, right? So you have to keep that in mind. One of the tricky things in C is that, you know, if you have something like this, that, if I didn't have this padding here, by the way, but you just had this is 2 bytes, 2 bytes, 2 bytes, 2 bytes, 2 bytes, that's 10 bytes. So it's not necessarily going to fall on a byte aligned address, right? So if you had an array of these things, you know, and each of these entries is 10 bytes, well, what's going to happen, depending on the compiler, of course, it could fall on a 8-byte alignment, or it could fall on a 4-byte alignment. Right, so we have 10 bytes, and the way that I figured it's falling is it's actually falling on a 4-byte alignment, so it's actually going to pad this structure to have an extra 2 bytes in the array, so that each of these entries, when you're iterating through it, actually falls on a 12-byte alignment. So that was an issue I was running into, because in here what I do is I pass in a double void pointer to the data, to the actual array, a void pointer to the key that I'm interested in, because I'm just interested in the bytes, the key length, and then the val length, coming through here, computing the entry size, which before wasn't doing this, which is byte aligning this to a 4-byte stride. And then when I was calculating this key and val length in order to do an offset to get the state for the entry, I also wasn't doing a 4-byte alignment. And so what that was doing was giving me garbage data, because I'm just grabbing, you know, whatever bytes and trying to interpret those bytes in a particular way, which actually, you know, didn't fall into that alignment. So did a lot of work on that. So now you can do, you know, technically it should be working, which actually I don't even need to have this padding anymore, and it should still work. If not, then I'm gonna have to go through and mess with the hash table again. See, I'm still getting, so I am getting some issues. So if I don't have this padding in here, I'm still getting issues. So it's still something I'm gonna have to go through and figure out. There's still something happening. But for now, I'll leave the padding. It's fine. Saeed asks, are you using F&V hashing? No, it's a SIP hash. And it's not my idea. This is totally stolen from Sean Barrett. In fact, it's directly from his STB. Let's see if I can find it. STB DS. Yeah, so his data structures library. Yeah, I'd never heard of SIP hash either, but reading through his library, so one of the things that people don't like C for is generic data structures are, at least in their mind, they're not existent. So you can't do things like an equivalent of an STD vector or an STD unordered map or stuff like that, right? And that was one thing that I struggled with for a while until I came across Sean Barrett's libraries and watching him describe it. And he was able to make a dynamic array that is completely generic. And then a hash table as well that's completely generic. And really with those two, yeah, it's a secured hash, but there's options in here that he provides where you can do non-secured versions. So really the security is, has to do with the seed, right? I don't give a shit about the security. I don't care, at least not for my purposes. I might throw something in here to where if you wanted a secure hash, you could do that. And you could use whatever seed you want. For now, I just use time. Or actually, I don't even use time. I have a static hash that I use, or a static seed. So it's, I guess, deterministic in a certain sense. But I don't really care about the security. But he has options in here to do that. That's just plain false. You can use void pointer. Yeah, right. But knowing the issue with that, right, is say, you pass it to some function, you have to know how to interpret that void pointer to be able to do something with it intelligently, which can be tricky. So it can be tricky to figure out how to do. It's not straightforward, right? But this is the SIP hash. It's kind of intense. Again, this is the type of thing that I could not tell you how it works. This is black box magic to me. I'd have to spend quite a bit of time to go through this and really understand what's going on. I have no idea. All I know is that it works. And, I publicly thank Sean Barrett for this. One thing I do need to implement in my my hash table right now is I use a linear probing. I need to use quadratic. This is much better. I'm starting to realize that as my, because I use an open addressing, I believe. I don't think it's closed addressing. Oh, what is it? I always forget which is which. What is open addressing versus closed? Which one uses... Something that always confuses me. And I've looked this up several times and I can never keep it in my head which is which probably means that the naming is not very good. So in closed, all stores are itself without the use of linked lists. Open is with linked lists. So that's the main difference. So linked lists versus non-linked lists. So I used, again, I just forgot again. My memory's terrible. I use closed addressing where it's just a flat array, right? That's the data structure. It's not a series of linked lists and buckets, which I think is what Sean Barrett uses for his. I use a closed addressing where it's just an array. So the downside of that is as the array grows, if you're using something like linear probing, you know, your probes get longer and longer, potentially, right? So you can do methods to solve that by using different probing methods. Right now I'm using the worst, which is just a linear probe. I'd like to increase that to at least do a quadratic probe. So that's something that I've made a note of to work on. But not today. Today we're going to work more on the immediate mode stuff. So kind of, again, going back to where I was, showing you what's working right now. So push and pop matrices are working, as you can tell. Lines right now I've started working on. Different raster, different pipeline states are possible. So blend mode, you can disable and enable. You can do depth, you can do face calling, stencil, you know, all that stuff is working right now. And various primitives. So a couple things I want to work on today is I'd like to continue working on doing various primitives with lines. So I have different utilities that I've already written from the previous versions. All I got to do is just put those into here and they should be working fine because they just rely on the line implementation working. And as you can see, it's working fine. And then start working on texturing. And after that, I need to do fonts so I could do debug text stuff. And then it should be good. Fonts are going to be weird because I don't really have a utility for holding game-specific assets yet. And fonts are definitely game-specific. Or at least they're application-specific. They're not, I don't consider them to be an internal resource. I'm not sure where I'm going to put that yet. So I'm going to have to make a decision on that. But for now, just going to start working on this stuff now. And as I go through, I'll start cleaning stuff up. So this should actually be a line 3D that it's calling. And again, I have other utilities for doing you know if C11 threads are available on Windows. I'm not a C11 expert. I use C99 at most, but Saeed uses it, so actually uses it quite a bit, so I'd listen to him. Okay, so got a rect with lines. Probably do like L, maybe that. Okay, so for rect lines. test this. So let's just do like a 2D. Push matrix, matrix projection. So what you do is you push on a new matrix, tell which mode you'd like to set. This is a little different from immediate mode in OpenGL, because what you would do in OpenGL is you would do GL push matrix, and then you would do GL matrix mode to set which mode you want. So it's 2 calls. I've just condensed that down into 1 call. That way there's no confusion. Because it's very easy to push a matrix and then forget to not set the matrix mode and accidentally, you know, mess with the model view matrix when you meant the projection matrix. So for now, it's you push it on and you set which mode you're going into. That way you can do it in 1 call, and then I could, you know, say start messing with that matrix. So I'm going to push on a projection matrix and then set it to a 2D camera. I should probably rename this to like camera UI or camera, you know, WS or window space or something like that. Because what this actually does is it gives you an orthographic camera that is set to where the coordinates are in pixel space on the monitor. So it gives you something where you can actually draw stuff in window coordinates very easily. So it's good for UI, basically. So if you need to debug UI stuff, then this is what you would use. Which is what we use for text as well, or at least 2D text. The only difference being that in order to keep rotations to where they're counterclockwise, the origin of the screen is at the bottom left corner instead of the top left corner, like you would typically do in Windows or window space. And again, that's just so that you can keep rotations to be counterclockwise. If that's weird and people would rather it be the other way around, to where 0, 0 is the top, I could do that, but the rotations are going to be flipped. So it's one of those give and take things. But so let's do this now. Let's make sure that this is actually working. So we'll pass in GSI. For the float, let's just do start at 100, 100, and we'll go to, oh wait, what was that? Go to 300, 300. We'll do white. You're hearing a lot of noise in the mic. Maybe the plug. Yeah, let me make sure that the connection's okay. Let me know if that's any better. If not, then great. It says my connection's okay, so I don't think it's anything with the bit rate. And I've changed those settings recently to what you guys are recommending. So, I'm not sure. screen. I hear distortions. Let me know if you guys still hear it. I turned off my music, so maybe that's what it was. Okay, so alright, so now we have a rectangle with lines. Okay. It's the kind of thing where if we wanted to make it a 3D camera, we could. We're not going to see it because we're actually off screen, so we need to go like 0, 0. So that we're in the center of the camera. So there we are. And then we can start rotating the thing. And let's say we rotate around the x-axis. Let's do that. Let's do x and z-axis. Smaller. Might be too small, but let's see. What? Should be changing size at least somewhat. Okay, there we go. Okay, so now we have a 2D rect. But we can, you know, everything is 3D coordinates, so we can translate it, rotate it, scale it, you know, homogeneous transformations like we would expect. We could set our blend mode, or our depth mode. True. Come on. I don't know if this is going to do anything. I think I'm always on top of the... I'm always on top of the circle sector, it looks like. Yeah. And then the other two are the other objects are transparent, so... Anyway, okay, so that's working. We could do a triangle with lines. Any books that I recommend on modern C++? Not really. No, I don't. I don't really have any. I'm sure someone else would. Hey, is the mic better? Is it still scratchy? Still distorted or anything? 'Cause if not, then cool. So let's try to do a box with lines. Mic is not fixed. Although, still scratchy. What the fuck? Yeah, I'm not sure. I mean, it might be the kind of thing where I'm gonna have to like start doing test streams before I start streaming, so, which is quite annoying, but oh well, I'll do it for you guys. So box lines. So we need, it's pretty much the original box. So Rudy says it's okay, so it's okay. I don't need this. I do need this. GSI begin. GSI, GSI, nope, GS graphics primitive lines. Okay. And we'll set the colors. So GSI C4UB. Maybe these guys have super nice head. Yeah, maybe. I'm sure Girome does. He's another YouTuber, by the way, guys. He does cool engine-related content. If you want to check him out. Mic is now fixed. Oh, you son of a bitch! You had me worried for no reason. GSI. There's no texture coordinate. So again, here I am setting in that cache, setting the texture coordinate for this to be 0 because they're lines, and then setting the color for all these vertices to be the passed in color that you gave. Okay. Which actually isn't necessary, I suppose, because I only have to do this because doing these lines will set all of this stuff here. So I don't even have to do this. Okay, let's draw a line 3D. We will use that, but we're going to change this. GSI line 3D, and we don't have a command buffer. We have the GSI object. So it would be nice to be able to pass in like a line 3D V. So let's do that. So do a vector version of this. So line 3D, line 3D V. Start maybe. End. Okay. So line 3D V. So for this, we'll just go to line 3D. So GSI line 3D. Please give me a hi, says Shane? How do you say your name? Is it Sean? Sean? Yeah, so it's one of those that I said. Shane or Sean. That helps. Hello, Sean. I'm assuming that's your name. Okay, so we got this line 3D V. So you should be able to pass in box lines, this. So let's just call our color. All right. That should be okay. Nope. Let's see, half extents. So we have a half extent. And we don't need to do this because we have that. X, Y, Z, half extent. Okay. Should still be good. Cool. But for over here, love from India. Awesome, man. Love from Texas. Let's see. GSI. Box. So let's do a box. Lines. Okay. So again, we do that. Let's just do, again, at the origin, our half extents, we'll just do a unit box, so it's a cube, and we'll do a red. Okay. Okay, so that seems to be working. Got a unit box here. Let's go ahead and push on a matrix. Matrix model view. And for this, let's scale it. Not necessary, you don't have to do this actually. You could just bake it into. That's interesting. So it's like there's some shearing or something going on. So rotate, then scale. So that looks good. And that looks good. Huh, so interesting. So I guess if I do too much, that doesn't make sense though. I should be able to rotate around. I shouldn't have to do this. You should be able to do this rotate F, pass that in, give you a rotation matrix, and it should be fine. Having to do this, for some reason this is skewing the vertices, which isn't correct. You guys see how that's like growing as it shouldn't be doing that. This should give the same functionality. Those should be the same. Shit. 0 point, let's just do 8. So I'm not sure what's causing that. It's weird. Let's actually look at that. So if we go over here, GSI rotate F. So it should give me an angle, X, Y, Z. Mat 4 rotate V. Maybe because it's assuming that this is a normalized axis. that actually might be the case. So maybe what I should do, normalize this, and then should do this instead. I think that's the problem, because I'm giving it a non-normalized axis. Yeah, so there we go. So now if I come into here, and now if I do this, this should give me the exact same rotation. Yeah, that was the problem. Fun times. So, stuff you got to look out for when you're writing your own math. So make sure you do shit correct. Mike asks, what would you recommend for learning OpenGL and graphics programming? Mike, I get asked this question probably once a week, if not more. I always give the same answer, which is go to learnopengl.com and get started there. He has a really good tutorial. The second addendum to that is that I'm just going to make an OpenGL tutorial series. I think I'm going to make it one long video, and it's going to have timestamp chapters in it, and it's going to go through pretty much everything. And then I'm going to start pointing people to that. But for now, go to learnopengl.com. Here, I'll write it in here. Go there. That's a really good resource. But yeah, I'd like to do an actual series. Because I figured, instead of giving someone else the traffic, I know this stuff. I make videos. I'll just make a video. And I like the idea of it being just a long video, right? So instead of a bunch of videos in a playlist that you got to go through, it's just going to be one long video, and again, time-stamped. So you just go to the description, and you're like, hey, I want to learn about vertex buffers, and then just click on the vertex buffer timestamp and just watch that, That just seems to be the easiest, most straightforward way to do it, and it seems the cleanest. Instead of scrolling through a playlist, right? It's like, where's the vertex buffer video? So, all right, cool. So we got this going. Fixed a rotation or a rotation vector issue. That's good. Which should mean that this now, because this was also acting kind of funky. Yeah, so now that's okay. Super duper. Yeah, that looks right. Sweet. And then if you want like a normal matrix or a normal to your line, so where's my line 3D? So some simple math for you guys. So what we've done is we have a projection matrix. So now we put ourselves in projection space of perspective. We're in a perspective projection, okay? And then we push on a model matrix. So now we're in the models space that we're dealing with. All right, so let's just get rid of some of this stuff. So let's not rotate, let's not scale it. Let's just draw a box, okay? So this box, when we're giving it these coordinates, we have to keep in mind what space we're in. Again, now we're in world space. And the box declaration here is you pass in the origin for the box. So right now, passing in 0, 0, 0. And then you pass in what are called half extents. So from the origin, how far out are you going to go in the negative x and positive x direction, the negative y and positive y direction, and then the negative and positive z direction. And then that gives you the extents for your box. Okay? And then RGB values for the color that you want the box to be. All right, so if we draw this, and actually I'll get rid of everything else, so we'll just see this. should just have a box in the center of the screen, okay, with orthographic projection, all right? And it's lined so you can actually see through it, right? So you can see all of the edges of the box, okay? If I make the half extents for one of these larger, so let's say we make this in the X direction 0.5 units larger than the other, then you'll see that it'll be kind of stretched in the X direction, okay? Let's get back to a unit. So there's a couple ways that we can actually manipulate this. We can either manipulate it in object space, and that's what we're passing in here for these coordinates. We're passing in the vertex declaration for an object space box, okay? So if we wanted to scale the thing by, 5 units, we could declare like a scale of 5, and then we can come in here and we can multiply all of our half extents by this scale. And now what we've effectively done is we made a box, it's off screen right now, but we've made a box that's, has a scale, a unit scale of 5, or a uniform scale of 5. We could do 0.5, so we could shrink the scale. We could also do it by like sine of the time. So now over time we're going to scale the box, shrink it, and grow it, right? But again, this isn't doing anything with any matrices or any of that stuff. This is just basically manipulating the vertex declaration for this box. That's all I'm doing, right? So you have some added benefits of this and downsides. The benefit of it being that I don't have to push on a new matrix. And the issue with pushing on a new matrix is that you're incurring a new draw call, right? So you push on a matrix, you have to do a new draw call because it has to go through all the buffered vertices that you had previously for that stacked up state, and it has to draw all that stuff, right? So if I have, let's see, like this, okay? So if I draw these lines out here, it's using whatever the projection model matrix were already on the stack in order to draw it. As soon as I push on a new matrix, then it needs to go ahead and make this draw call. That way the model matrix and the projection matrix that are on the stack actually get used for that line declaration respectively, okay? So if I do this, I should have, actually you probably won't even, well, you'll see it. Okay, so this is now 2 draw calls that's been incurred, right? If I put this inside of here, it's now 1 draw call because it's able to use the same matrix stack in order to buffer all those vertices together in order to do a single call. So that's something to keep in mind for this system. So one of the good things about doing this for this scale is instead of pushing on a new matrix, I'm not having to do another call, right? So if it's something as simple as this, I don't have to do another draw call. I could just do the scale the way it's doing it right now, and it's all doing it in a single draw call, okay? The downside of this is that if you wanted to start doing more complex transformations, then what you're gonna have to do is you're gonna have to go through and transform your verts, every single one, and that's gonna, well, cause a lot of issues, right? So at that point, it's probably worth it to just push on a new model matrix and then do what you need to do. Alex asks, is this software rendering? Nope, this is actually using, so for the graphics, let's see, just graphics. So the graphics backend is actually it's a wrapper around, it's an explicit pipeline, okay? So it models after DX12 and Vulkan. So what that means is that you're very explicitly setting up your render passes, your pipelines, your shaders, uniform buffers, samplers, vertex buffers, all that kind of stuff. And then to actually use that stuff, you pull up commands inside of a command buffer that I have, and this is mainly just for multi-threaded rendering. But you pull up commands out of that, and then here's your main draw commands, right? So it's very small. It's very similar to Vulkan, really, but it works. Now what I'm doing now, and actually if you look up here, here's an example of actually using this, which I've gone over in previous streams, using this to do rendering to an off-screen texture, and then blending that texture to the back buffer. So again, all this stuff, you set up a new command buffer, you set up your shader, create the shader with a descriptor object, you set up your uniform buffer for your uniform, for all your uniforms rather. Same thing for the sampler, generating a new texture, a render target that you're going to use, the frame buffer that you're going to use, vertex data, like all this stuff is very explicit, right? So none of this is, I guess you could do this in software rendering, which I'd have plans to do in the future, and I'm not drawing into this stuff right now, because right now I'm focusing on the immediate mode stuff. But the immediate mode, what it does is it's a debug util, but in the back end, whenever you actually create the immediate mode util, it's doing all this in the back for you, right? So it sets up the uniform buffer, sets up a sampler buffer, sets up shader, it sets up a default texture, and then it sets up all the different pipelines that are possible, right? So I was explaining this earlier, that for the immediate mode, it's just a debug mode utility that I'm using, or that I'm creating, so that it's simple to do like debug rendering, right? If you have like you're doing physics objects and you need to draw like the physics shapes, it'd be nice to be able to have some kind of debug util. Actually, it's very necessary to have some kind of debug util to be able to draw like all your physics objects, because you can't really see those. So that's what this is. But so you have different configurable states. You have depth, stencil, face call, blend, and primitive. Each of those creates unique combinations. You have 32 generated pipelines from those combinations that are possible. And so when you go in and you say, like enable the blend, enable the depth, stuff like that, then what it does, actually look at that. It checks to see whether or not the current cached pipeline state has the depth enabled. If it does, then you don't have to do anything. Otherwise, then we need to flush all the previous content because we're about to switch pipelines. Then we set our pipeline state to be enabled, and then we look in our hash table of all of our pipelines, and we hash the pipeline state attributes. That hashes down to a 64-bit key, and then it gives you back a handle to the pipeline. So that's how that works. And for any state that can change, it does that. So any bindable state. All right. So like I was saying, this is something you could do to keep you from having to do any more draw calls than necessary if it was something simple like this. So we could do this, but what we could also do is push on a scale matrix or change the scale that's for our matrix rather. But now you see what's changed. So before, the rect that we had in the center wasn't getting affected by the model matrix, or it just wasn't getting affected by the scale, because now we've moved the scale out of the object declaration for the box and we moved it into the model view matrix that affects the entire draw call basically, right? So again, the difference being these two, right? So now it's not affecting it. So again, just something to keep in mind, what's possible. Okay, so now we're affecting all that. And another way that you could do this without affecting the other rectangle is to actually wrap this inside of a push matrix. Again, keep in mind that whenever you do that, you've now incurred another draw call where you didn't before, which in this case might not be necessary, but let's say that we start rotating the thing and we start translating the thing. Maybe Z coordinate. It's kind of interesting because it gives the effect that it's moving back in Z space, but really it's just scaling. So, all right, that's enough explanation. So we've got box with lines. Let's do spheres. Love the keyboard smack. Yeah, if it's annoying, I'm sorry. I've been told that I type really aggressively. Sphere lines implementation. Okay, they don't sound like switches, are they? No, it's a regular, like a Logitech $10 keyboard, little USB. Like I said, I type pretty aggressively. I do have a keyboard with switches in my closet. I just never pull it out because it's just so loud, and I feel like I'm just annoying my wife with it. So, she says it doesn't, but I don't believe her. So it's not vert 3F. GSI C4UB. Actually, we need to begin lines. So we do need to do that. It depends. I've worked in offices where you had people with switches, like at the game studio I was at for a while. We had some people with switches in there, and sometimes it was fine, but after a while they do get pretty annoying to listen to. My wife kicked me out of the kicked my office out of our bedroom when I bought the keyboard switch. Hey, maybe that was a good thing. GSI V3F. degree to radian. No CB, this is GSI. And I think that's it. Let me set the text coordinates. Okay, now I should be able to do sphere. And we'll do again, we'll just do it 0, 0. We'll do 1, and we'll do this one green. Well, it's there. It's a little big though. Okay. All right. So now we've got a sphere. Again, could rotate the thing. Don says, you were the first person I've ever seen use multi-cursor editing in real code. It's one of the reasons why I like Sublime. Being able to do, if I want to highlight multiple things and then edit, it makes it so much faster. And I don't ever touch the mouse. I don't need to, because I use Vim. Vim commands, anyway. GS platform, elapsed time. See, again, just do whatever. Okay, so now all those are rotating around the X and Z axis with respect to time. Give it the Y axis as well, because why not? Now we get different rotation. Set that to be a little cool. I don't think if I set depth on, it'll do anything because of the lines. It might, but oh yeah, this probably looks terrible on YouTube for the compression settings, just because it's probably just because how fast it's moving. Let me slow it down. It's a good point. Maybe that's better. Let YouTube catch up. Again, so we have a 2D rectangle, quote unquote 2D, that's being transformed in 3D space. We have a box with lines that's being transformed in 3D space, obviously, and then a sphere with lines being transformed in 3D space. Good. I'm glad that's better. I'll try to keep that in mind. I tend to work I just work without thinking about the environment that I'm in. So one thing I have to always keep in mind is, all right, you got to, make your text bigger. And then I guess in this case, now I'm going to have to think about, don't make things rotate so fast or move so fast. So, okay. So we have spheres. Sphere with lines, sphere. Which what I might do is, instead of this, because this is the exact same declaration as just regular sphere, but so I might do instead is do like here's also picking red and green. I see. So those colors as well are bad for the compression. Okay. So if I do, Is it the primitive colors? Is that what's bad? So if I do R, G, or B, just pure those, then that freaks out? Is that what you're saying, Leon? I don't know enough about YouTube or about just compression in general across video streams to know what's good and bad. It's something that I have to look into. For colorblind people. Oh, I see. It's for my colorblind folk. Okay. So, here, I'll do this. There. Is that better? Is that worse? Does that make is that even worse for colorblind? Those colors? Like a magenta and then a teal? Okay, so I'm gonna need to go through and add, let's see, a triangle with lines. I'm going to have to add spheres, or I have spheres. Add circles, like a line with circles. What else? Triangle. I'm going to add cones, cylinder. And then that'll cover pretty much all the primitives for lines. And then let's do textures is the thing I'm going to have to do next. How about pulsing or cycling line colors? I'm sure that'd be great for the compression, Don. Unless you're just asking about how would you do that. Otherwise, you're asking like, oh geez, let's do this. So F32R. Oh, I see. Valerio asks, would you be interested in making a C OpenGL tutorial? I was just talking about that a little bit ago, Valerio, and yeah, that's something I'm planning on doing. I think it's time. No, this is my R. Let's do 100 again. We can speed that up. I know that might be moving too fast for the compression. But I'll let y'all look at that for a second. I'm gonna go get some more coffee. Be right back. If they change the distance between them, not sure if that's true. That might be the case, Don. I need to look at that. That's interesting. Yeah, what would have been tricky is if you had like the line, like the colors, like a multicolored line, right? So you had the line color pulsing through the sphere. Does that make sense? Because that's where my mind went. That would have been tricky. Kind of. I just have to do a multi-line color declaration, and then it would blend the line between them. But it would still be kind of tricky to do. C2 says it looks like a old Windows Media Player visualization. Yeah, kind of, doesn't it? Which we could make something like that. That wouldn't be too hard. Wouldn't be too hard at all. Maybe we do that someday. Because really all you would have to do is load up your audio that you want. And then as you're submitting audio samples, you would grab at that particular point in time for each of those samples, you would grab the volume for the sample, right? And then you would just do whatever you want with that data, because the interpolation that you do for the volume, you could use like color. It's basically a scalar at that point, right? So use the scalar in order to do some kind of interpolation value, whether it be height on a histogram or something like that, or it's the color for an object, whatever. Are you using VAO and VBO? Yes, I am. So this is different from actual immediate mode. This is an abstraction on top of the explicit rendering that I have. So again, if I go into here and look at what the immediate mode object actually holds, it holds a vertex buffer. So it's a handle to a resource that's internal to the graphics subsystem, holds an index buffer, all this stuff that you need, holds a pipeline table. And then in the graphics implementation, this actually holds a single VAO in this data cache, holds a single VAO that's bound, and you just need one VAO for the OpenGL application. So modern OpenGL is different from legacy, or at least before 3.3. I think after 3.3 you have to have a VAO bound, but you can switch between vertex buffers and index buffers within that VAO. You don't have to use it, which actually is a decent idea to do, because VAO switching is very expensive. So if you can minimize it, as much as possible, then go ahead and do that. So what I do is I bind a single VAO and then I don't touch it. And then what you do for your pipelines is you create vertex buffers, create your index buffers, and then you assign those through your bindings. So in here it's assigning vertex buffers and index buffers, uniform buffers and sampler buffers. And then for the draw, what it does is it looks at the pipeline, grabs the layout, and then it enables the attrib pointers for the VAO to be able to look into the vertex information to know like stride and all that kind of stuff. One thing I don't do right now, which I will do in the future, is have the ability inside of the pipeline to be able to designate the ability to designate like what is the vertex stride and what is the offset for each of the buffers. Because if you wanted to have something that's that's non-interleaved, if you just wanted to have like, here's all of my position data, here's all of my color data, and it's just big blocks of it, you should be able to do that. And right now I don't allow that. Right now it's all interleaved data. So I need to allow the user to be able to do that because it's useful. If you want to designate your data that way, you should be able to. So, but yeah, so here it comes through, it enables all that stuff, sets up the trip pointers, and then it reads out the start and the count for what you're drawing. And then it looks to see what the primitive type is that's bound. So if it's lines, quads, triangle strips, whatever. Gets the index type. You need the size of the index stride, basically, so that you can tell Opengl what to use. And then whether or not you have an index buffer bound, it'll either draw elements or it'll draw arrays. So that's kind of that's how the draw function works for the Opengl implementation. Okay. So sphere, lines. No, not in here. What else did I say we need? We need triangles. So I think I have that already. Maybe I don't. Thought I did. Oh well. Doing a triangle with lines isn't difficult though, so just whatever. I'll just do it. Triangle. Yeah, anytime done, of course. Sphere lines. This is already starting to get kind of messy. I'd like to clean it up. So what do we do for this? So we'll begin graphic primitive lines, end, and V2F. So you want the first one to go. So we'll start at x0, y0. So you want 3 lines for a triangle. So x0 to y0. Oh yeah, you just need to do this. I don't know why I'm thinking about this. x1, y1, x2, y2. That's it. Done. And then we need to set GSI for CUB. TC2F. Okay, that really should be it. So again, a lot of these declarations are the same. So what I might do is do like void GSI triangle, and then inside of here, have all this normal stuff, and then you have like a primitive type. Right, and then whether or not you do lines or you do triangles, we'll decide whether or not it's filled. I don't know. That way I don't have to continue to write these functions. I think that might be the cleaner way to do it. All right. GSI. Again, we'll do just a unit triangle. Yep. And let's make it same thing. Oh. Okay, so just have that line. So if we do 0, 0, 1, 0, 0.5, 1.f, that should be fine. Right? That should be a triangle declaration. 0, 1, 2, 0, 1, 2. 0, 1, 2. Let's do this. So let's give it that, and then we're actually going to give it a graphics type. Going to do what I said I was going to do, and if I go to GSI begin, so if you don't pass in either line or if you don't pass in either lines or triangles, then I'm just going to manually set that. GSI triangle. Okay. Draw rect, which in this case GSI triangle lines. Okay, so I think my vertex decal is just not right. Also, I have to do this. Okay. So I have a triangle up here. Let me just use this declaration. So I think mine. Uh-huh. Interesting. Let's see. Why would that be messed up? Interesting. Hey, VMA. Hey, Salmon Cat. Let me just look at that. So yeah, that's not correct. Also, I'm sure you guys cannot see that, so let me just make this bright white. So I'm trying to draw a triangle with lines, and I'm just getting the single line. Pulsing does destroy the compression. Yeah, that sucks. Even when it's that slow. Well, I could slow it down even more. So that should be better. Actually, I'm going to do that. so sphere lines, we're going to get rid of that. We're actually going to do the same thing. So GF's graphics primitive type. So rect lines, we're going to get rid of that. What else? Alright, so you just pass in the primitive type. Cool. So actually, this will let me know whether or not this is messed up. Box lines. So here we're doing line 3dv. Actually, I'm going to get rid of this. So GSI box. So I guess what we could do, switch on type. I'll just do that. So okay. Triangles, we're going to do this. Alrighty, and then if we do lines, we're going to do this. Should be good. UEV. Actually, these UVs I do not need. Okay, so now I can get rid of that box lines stuff. Begin type. Make sure this is actually the same. This might not be the same. 3, 4, 5, 6. Yeah, this should be the same. Looks like it. Okay, it is. Okay, cool. And these are primitives, so let's just go ahead and get rid of, put these up there next to triangles. Just make sure I don't have any declarations that are not being used. So we've got box, sphere, so I might do a triangle 3D just to round this out. I don't know. But now this is a lot simpler, right? So we have a rectangle, you know, you give it the same parameters that you would, but then you specify a type that you'd like to draw that in. So whether it be lines or triangles, triangles will be filled, you know, lines will be lines. Same thing for all the others, so box and sphere. Okay. When it comes down to textures, this is going to be interesting. Because if you want to do like a textured box, right? I'd like to be able to have some kind of method for, oh yeah, I need to do this. Okay. And then in main, I'm trying to do sphere lines, which does not exist. It's just sphere, and then we pass it should be the same. It is. Oh. Well, that's interesting. So it's not the same. So what I'm going to do is this is the triangle declaration. And this should be the line declaration. Fun. Okay, now I need to go back to okay, what else am I missing? Oh yeah, down here. GSI lines, undeclared. Oh, that's right. Okay, so now that looks right. And then I could switch between the two. So instead of this, we could do triangles instead. And now it's a full sphere. So Let's not do that, but let's do face culling. Okay. So now we're not seeing the internal faces. I should have blend on. I think that's fine. Yeah, it's whatever. Ooh. What the hell? Oh, it's because I have... Huh, interesting. That's cool. Wow, that's weird. Strange. Is it because of face culling? No. Because of the blend? What the hell? What did I change? That's not good. It's not good at all. So the line declarations getting pushed back is wrong. Yeah, shit. Fantastic. That's interesting. Well, I'm not sure what's up with that. Maybe it's because of the texture coordinate. Which I've had weird stuff happen with this before. No, it's not. So it's literally something with the line declaration. There's a line, there's a line, there's a line. Fascinating. Because the way this works for this is that that's a vertex, or a triangle, and then that's a triangle. And then for this pair makes a line, this pair makes a line, and then this pair makes a line. I'm not sure what's going on with that. What's different between these two? I wonder. sure this will not compile. Yeah. Line 3D, X, Y, Z, X, Y, Z, RGBA, right? Yeah. So we have this, got this guy, times that, times that. Oh, because I'm doing this GSI there, that's why. Huh? Still incorrect. Man, that sucks. Yup, this sphere is ruining it. Not just the sphere, the rect too. Damn it. Okay, what's going on here? Let's step through. And let's see. Sneaking suspicion that it's not binding correctly. Oh yeah, because if I'm doing a triangle with lines, then that's not right. Okay. So I think that one's at least wrong. Okay, so So this is fine, this is fine, except it's not. So we want to go from a line that goes, so let's just do this. There's our line. Oh yeah. Okay. So I think that fixed the triangle as well. It did. Okay. Sweet. So I should have like a good box now. No. Okay, so the box is working. Is my sphere correct now, or is it still messed up? And my sphere is good. Okay, so that was the issue. So doing the triangle, I wasn't passing back enough vertex information, but now it's good. Commander Shepard. Dear John, how do I become a silver fox sea god like you? Oh, that's nice of you. Although the silver fox, what are you saying, I'm old? How to be good at C? Just make stuff in it, I guess. Because I used to suck at C. There are areas where I'm still really bad at C. Also, I'm going to do a few more tutorial series with like OpenGL and maybe some C stuff. Cool, so we have sphere with lines and triangles, rect with lines and triangles, triangles with lines and triangles, boxes with lines and triangles, right? So at any point we can come in here, which, let's do this. So if GS platform key pressed GS key code, I don't know, L, let's say down, and we can just do this. So GS graphics primitive type equals, so let's do a switch on this. So what we're going to do is for our sphere, whether or not we have the L key held down, we'll switch between triangle rendering and line rendering. Oh, that's probably great for the YouTube compression if I just do that, right? Okay. So that's working fine. Okay. Also, another thing to keep in mind is when I was switching back and forth between those, it was actually doing a different draw call because the primitive was changing. Okay. All right. So this has been good. Let's go ahead and commit just in case stuff. What compiler do I use? Asks Ferric. Right now this is using MSVC, but it can also use MinGW. So let me compile this just to make sure. I actually haven't compiled with this today, so just making sure. Yeah, so that's still good. It can also compile with Clang. And then it works on Mac and Linux as well, using GCC for those. But you can use Clang. I give you all the options. Use what you want. Okay. Render pass, begin pipeline. Oh, Jesus. Why not use C++? I do not like C++. There are some useful features. I don't agree. Do you have a make file? Nope. I use bat files and bash files. That's it. My build process. You go on this procedure. So you have Linux. There's a bash file. Here's a bash file. And then for Windows, this is it. So I used to use all kinds of complex build systems, mainly CMake, and generating all that crap. Now I just use bat files and bash files because they are dead simple and they do everything that I want them to do. And they're tiny and I can understand them, and I don't have to go read documentation on the new version of CMake and why this particular flag isn't working anymore and all this other kind of crap. I can just write a bat file and it works, which is what I want. Fewer dependencies as possible is my philosophy these days. Yeah, I agree, Don. They are overkill. Because eventually you get to a point where the amount of time that you saved using a build system is wasted in trying to debug the build system itself. I've never had to debug a bat file. At least, 10 minutes out of my year, Okay. And then we can enable all this other stuff. And this should all, triangle, we have to pass in all this other stuff that we want. So, where U is, okay. Graphics primitive triangles. Same thing for this. Same thing for this. Same thing for this. So now we should have all this other stuff that was drawn before. Yeah. Sweet. If you have a really big project, simple scripts don't cut it. This entire project is let's see, for the interface and basic implementation, it's 4,600 lines of code. For the graphics implementation, which is just OpenGL specific, 1,500 lines. This is the utility for the immediate mode. That's another 1,000 lines. Then I have a platform implementation, which is just GLFW specific right now. It's close to 1,000 lines. Audio implementation, it's 500 lines. It's the smallest implementation file that I have, is the audio. And that's only because it's using mini audio. So it's a mini audio implementation. When I start writing more platform unique specific implementations, because mini audio is a platform layer, or it's an audio abstraction layer in itself. So it handles Windows, Mac, and Linux. So I mean, all that together, that's what, I don't know, close to 10,000 lines maybe. And this is the build. So I mean, sure, I guess. Also, it doesn't matter, as I continue to add stuff into here, this will never change, ever. This will be the build for a simple project that uses the Gunslinger library. This is it. Will never change. Why? Because it's a header-only library. So you want to, right? Because like this entire app I'm using is just it's a template for like what a Gunslinger project would look like. I think I've done this before where I showed what the simplest Gunslinger file would look like. So like let's look at that. It's like that's the simplest Gunslinger project you can have, is this. And again, that's how fast it compiles. That's compiling the entire header-only library into your project. So what, a second? I don't know. So I've gotten people that ask me before, like, oh, you're doing header only, doesn't that increase your compile times? It's like, if that's too much for you, then I don't know what to say. Like, that's ridiculously fast compared to like C++ projects I've been on before. Do you use GLFW for the window? Yeah, so for the included platform implementation. So let me go over a little bit. I've done this before, but let me go over a little bit of the way this works. So whenever you're including, if you ever used any header-only libraries, like the SDB libs really kind of made this popular. Typically what you do is you'll define an interface and then you'll define an implementation. So what you have to do is whenever you're including this, you need to define the implementation. So say that this particular source file is going to be the translation unit that has the implementation in it, and then you include the library. And so what this does is it actually dumps everything into this file, and then it compiles it all together. Okay, so it's a single compile, single translation unit, which actually does speed things up. And then you have different areas that have implementations. So I have a util area, I have containers, math, platform, graphics, audio, all that kind of stuff. Okay. These implementation files for these particular things serve two functions. One being that if I dumped it all into here, which I could do, then it would be impossible to load it up in a text editor into a single file. It'd be too much, and you wouldn't be able to see it on GitHub. So if you wanted to view the code on GitHub, you wouldn't be able to. So what the header file for this is, this gs.h, it's the main interface file. So if we go to something like platform layer, this is the main platform interface that the user can use. So it has various defines, such as like key codes and all that kind of stuff, different callbacks. This is the actual platform interface. So this holds all of the data, including handle to all the windows that you could have open, platform input, platform time, different settings for like video settings, stuff like that. And then here's the API that you can use for the platform, right? So create and destroy, init and shut down all of your platform stuff, getting key codes, has other things like file utils, being able to get UUIDs, generating UUIDs, and then various other stuff. Okay. And then what I do is down in the actual implementation for the engine. Okay. So here's the actual implementation. So this only gets included if you have this implementation defined set. Then what it does is it actually goes through and starts implementing the actual functions that are declared as externals. So camera, all this kind of stuff. This will probably go away. And then here for the different interfaces, so here's platform, here's graphics, here's audio. you'll notice here that they have their own implementations that are defined. So what I said in earlier video is what I'll do is get rid of this and instead have something that's just platform, like define GS platform implementation, or there'll be like a config file, like a user config, where you can define what you want the implementation to be in that config, something like that, right? So this would be like gsconfig.h, and it would have these defines in there that you can define. But if we go to the actual platform implementation over here, so we have a default implementation, which has some default stuff in it, specifically for like window creation, all that kind of stuff, because it has to push back handles into the slot array. UID stuff, that's all default. But then yeah, setting all the input stuff is all default. But then we have an actual GLFW implementation, which this does all GLFW specific stuff. So again, we could also have like, let's say that, you know, because I want to do like a Raspberry Pi, so we could do like Raspi. Okay. And then in here, I would need to fill out, if we go back to the platform layer, all the API stuff that is externed. So like all of this stuff, I would have to fill that out inside of the Raspberry Pi implementation. And then I do the same thing for like, you know, web and using WebGL and all that kind of stuff. So that's the basic scheme of how these all these subsystems work. This is why I love Pragma once. Yeah, I mean, you can use whatever. I'm just used to using include guards, so I use them. I know now Pragma once is, it doesn't matter on the compiler. It's supported across all major compilers. But at one point it wasn't, and I got used to doing this, and now I just do it. So this GS main, let me go over that real quick. So there is a decal here. So there's a decal here for GS main. So if you don't want main to be hijacked, then you could declare this, and then you can declare this main function yourself, right? But this is all that the GS main does. Is that it sets up this, creates an engine for you, right? It calls GS main, creates an engine, does all that stuff. So that's why this is the simplest program you can run in Gunslinger. So what it does, it just creates an empty, just creates a default window for you. Now there's no keyboard input that's getting registered. You're not doing an update function. You're not doing any of that stuff. If you want to do something a little more advanced, you could do like an update function. And then pass in that to here. So that registers a callback. And so now we're printing this here over and over and over, right? Because we're calling into that every frame. Which we can now look for keyboard input. So let's say if we hit the escape key, then we're going to kill the program, which I can't remember. I think there's a function I call. So if you hit the escape key, yeah, GS engine quit, that's what it is. So this just kills the program. So now when I hit escape, it'll kill the program. All right, I have to run. Time to get working on firmware code stuff. Yeah, I'm gonna have to go here in a second as well. Probably about 5 minutes or so. Is that a virtual function? Which virtual function are you talking about? There aren't any virtual functions in C. They're just function pointers. So in this app description, you just set that you want the update function that's going to be run for your application to be this app update. Right, I can call that whatever. Yeah, it's just a function pointer. Yeah, just a function pointer. So this is the app description. So it's a descriptor object that you pass in to the engine create. So you have an initialization, update, and a shutdown function that you can pass through pointer. You have a window title, initial window height and width, window flags, so whether or not you want to be resizable, full screen, all that kind of stuff. So frame rate that you want, if you want to enable the VSync, this is running, will get set for you. So this is what gets checked every frame. And then user data. So what we could do actually is grab like something like that, where you actually grab the global context for the engine, which I think that's right. Oh, that's what it is. And then we just set the is running to false, and then there you go. Which is what this GS engine quit is doing. It just sets the is running flag to false. Yep. But this is the simplest thing you could do. But what I'd like to be able to do, so let's work on this a little bit. So underneath here, after you define the main Gunslinger implementation and library, you can then start to do utilities. So this immediate draw is not included in the core library. It's actually a util library that's written on top of everything that you can use for like debug stuff. How did you set the frame rate? I'm trying to, but it stutters. So this is a little different than probably what you're using Salmon Cat if you're using the old Gunslinger, but it did have an application description, so it should be the same. It's actually, I'll pull up what it used to look like. So if we go to, let's go to like hello.js. So it's the same thing. It's an application descriptor. So it should be an app frame rate, and then you can pass in what you want the hertz to be. And it's set in hertz, so it's not set in milliseconds. So if you want it 60 hertz, you could do 60, which is 60 FPS. For this, it's the same way. If I do frame rate equals 60, then it'll do that. It defaults to 60, by the way. You're writing your own engine. Oh, well. So you don't set frame rate then. You're gonna have to, so the way it does it in Gunslinger, the way it does is it actually grabs platform time. So however you have to do that given your platform, and then it calculates a delta between the previous frame and then the current frame. And then what it does is that it sleeps the platform, or sleeps your application, calling into the OS, tells it to sleep if it is over or under a specific target. And it does all this. So the setting the frame rate is something that's application specific, and it's something you have to do yourself. You can't just tell a program to be a certain frame rate. But let's try to get something up real quick. I want to see how quick and easy it is to get like GSI going. So if we do a void init yeah, no problem. So we'll do an init and yeah. So let's just try to do like some simple immediate mode stuff. Like the simplest one. Let's just grab this. Let's do this again. Do a default render pass and then submit. Let's make this as simple as possible. CB, we're not doing this. We don't necessarily even need to set the viewport. Let's do camera 3D. Get all this stuff going. Let's just do our sphere. I don't know if this will work. Okay. So that was the simplest. I think that's, actually you don't even need to do this. I think you could just do this. Should get the same, yep. However, you probably do want an action so that you're clearing. Because if I were to start rotating this thing, clearing by default. Yeah. So if you don't clear the screen, that's probably great for the okay. All right. Okay, what physics library do you use? I do not use a physics library. I'll probably write my own. Do you have object loading? I don't have object loading yet. GLTF, that's the standard. I'm probably going to support GLTF loading and write a utility for doing that. And I'd like to do that soon. But yeah, this is just kind of showing, so this is, if you wanted to use the immediate mode rendering utility, this would be the simplest program you could do. Like the simplest one to get a 3D camera and then rotate a sphere. Right, so you do your immediate mode rendering, set up a 3D camera, rotate it based on the time, and then draw a sphere. Set up a render pass action, which for this case we're just going to clear to a color, and then set up your render pass, draw all of your immediate mode stuff, in the render pass, and then finally submit the command buffer. So yeah, I think it's pretty straightforward, pretty simple. But I'm gonna have to go now. Are you going to use an ECS? I'll probably have a utility that sits on top of this. I'm not going to have any of that stuff in the core framework because that is very game specific. But what I'll probably do is write my idea of an ECS implementation and include it as a util. So it'll be kind of similar to what this immediate mode stuff is. It sits on top, and you can include it or not include it if you don't want to. So that's it. Again, so it'll probably be something like define GS, I don't know, ECS implementation or GS game implementation. I have no idea what I'm going to call that. You're making your own and it's really hard. Yeah, it depends. Depends on what you need it for. They're not necessary. And you have a GitHub? Yes, I do. Let me get that. You'd like to see if you can compile it. So the version that's up right now is not what you're looking at here. So this is the header only version that I'm working on. The one that's up there is one that you have to compile to a static lib and then you link to it. It's pretty simple still, but with this, there's no intermediate step of compiling to a static library. If you don't want to, you can just drop it in as a header only library. See, how does the renderer creation work? I use libraries like SDL where I treat it as a black box. I'm not 100% sure what you're asking, Commander. Visual C++ will be okay. Yeah, it can compile for C++. It should be fine. So it's written in C99. And the only thing that I have to watch out for is struct initialization, which I'm careful about doing that in the interface. So I don't do C99 or C specific things like that in any of the interfaces. Or any of the code, really. The overall idea behind this is to finish all this up, make a video about it, show how to go over it, or how to use it, basically. So give you kind of like a rundown like I did this, do a small example. I've said it before, I'll probably make Pong. Like, how do you make Pong? And I'll show how to do that using immediate mode, and then I might do it using the more explicit renderer as well. And then yeah, probably do a game jam. Kind of the idea. Skiller Raptor asks, wait, what's the goal of this? The goal originally was to make a utility for myself so I could make tools and visualizations. I use this for my videos as well. The goal now is to turn what I had into a header-only library, and it's almost all the way there. Right now I'm working on the immediate mode debug utility that kind of sits on top. But everything that was there before is it's in there now working. It's actually even better, in particular the graphics subsystem, because now it's no longer an implicit subsystem. It is no longer an implicit subsystem. It's a explicit as well. And the overall goal is to, I don't know, get some use out of it and possibly get people to be interested in using it. It's kind of, the idea is to make it like Raylib, but much more granular, and extend it to where it has Vulkan and DX12 backends. Because Raylib is not set up for that. Let's see, could I use my own engine in your jam? If I do just a generic game jam, I think I'll get more people, so that might be something I say sure. What I would like to do though is, the main idea behind the jam was to get some use out of this library and then get people familiar with it. So I would encourage possibly using Gunslinger, but I understand that you're wanting to do your own thing, so I'll probably say sure. Go for it. I wouldn't want to exclude people who don't want to use Gunslinger. That's the idea. So, sure. How did you make the Gunslinger ASCII text? There's like an ASCII art generator online. So, it's in its early stages, so it'll be a while before I can write a game with it. If you mean your engine, then yeah, I understand. The idea behind Gunslinger is, by the time we get to the jam, you should be able to do most of everything. In fact, right now you can. I mean, you can. It's a fully functioning graphics backend, audio platform. You know, has all those things that you would need to do it. So. And ideally, you know, as things are shown off using Gunslinger, that's when people start to get interested in it. Right now, people, I don't think they can see the potential. I think that's the thing. They don't see the potential. It's not until you start seeing things being made with it that you're like, oh, okay, I can do that. All right. Well, like I said, I'm going to have to go. So I will talk to you guys later. Be sure to like the stream, subscribe, do all that stuff. We'll continue doing more streams like this until we get to the release, where I'll do like I said, an actual video. And then, yeah, join the Discord too if you want to jump in and continue talking about stuff. Okay. I will see everyone later. Thanks for dropping in.